How about this?
Can you hear me?
I can hear you.
We're getting better at this every time. Now I can see
Am I
you.
visible? I realized I had
Yes.
a different webcam. So I just changed over.
It was just totally dark.
Yeah,
Yeah.
I had a Microsoft one. And it didn't, let me see if I can make all this pointing and all. I need a cameraman for sure. Or something. And we need an IT guy.
Is there a budget for that?
I'm not sure. We'll have to talk to the boss.
We'll have to talk to the boss.
Yeah. So sort of part of all this is, you know, I've been talking about cutting dovetails and edge jig stuff, and you've been doing half blind dovetails, and I've got a couple questions on how does that work? You know, you can't draw them in CAD software easily. You certainly can't toolpath them. That is the gizmo, and you've made a bajillion of them.
I did, and what I'm showing you here are this is a sample drawer, and there are like 4 different problems on the same drawer. So it's not as simple as just cutting the joint.
Yeah. Well, see, I'm going to start this discussion. This is a Bill Confuses Everybody session of the Stuart and Bill Show. And I'm going to start by saying, first, set up your edge jig so that it's true and plumb and square and it's absolutely perfect. That's step 1. Get that out of the way. And we can talk about that in another session, but that's another, you know, it's got to be absolutely perfectly square, plumb, 90 degrees, everything's absolutely just right, or they're not going to turn out.
Right.
And you've learned that lesson. But once you have that done, it's still weird to try to figure out a way to cut the dovetails, to do a toolpath for them. The software just, CAM software in general doesn't understand being able to do undercuts and all that kind of weird stuff. So I'm going to try to explain in a not horribly confusing way how that works and how I do it. And hopefully it'll make sense a week from now if you think about it a little bit. But let's see if this works. Let's try this show. Let's see. All right.
This is also assuming that we have officially fired the hungover guy.
What happened here? Oh my gosh, I changed screens. Okay. So I just shifted. I've got 2 monitors. I just shifted to the other monitor. Let's see if I can shift this back over. No, I can't. So can you see any of the screen?
Yeah, I see a dovetail joint.
Okay. So this is going to be kind of weird because I'm looking at one screen and you're on the other screen. But basically, this is what we're talking about, is these dovetails. They don't go all the way through. They so they look like that.
Yep.
And you got a piece. They cut a pocket in one piece, and as sort of a dovetail on the other. You know, so. And to cut them though, since you can't cut this one from the top, this green one, you know, because there's wood in the way. You have to cut them. Look, isn't this fancy? This animation stuff.
Man, look at you.
So this is you have to cut them inside out and backwards, basically.
Right.
So you flip the boards over. So this is the inside face
of the drawer, and
this
the box.
Inside face of the drawer.
Yep.
And the cool thing about it though is if you do it just right and line it up right, it's sort of a continuous thing. You do this sort of scallopy kind of thing, and it cuts them both at the same time. You could cut them as, you could cut this board just as one thing, and then cut this board separately. But it'd be really inefficient, and you'd have to worry about it getting lined up. I mean, you could just kind of set up and do a toolpath for this and cut 100 of these, and then cut 100 of those. But being able to do them this way is way, way more efficient. They're paired, you know exactly. So here's the trick. So this is the bit that this is a 14 degree ½ inch. This is the one I've originally been working with. And it's ½ inch at the bottom, 14 degree. And sort of looks like that. I just drew it in CAD.
And Bill, those are the dimensions that matter for the folks that are interested in this.
The half inch.
Is the width at the bottom of the dovetail and the angle. Because basically, if you know those two things, you can line the joint up properly.
Right. You're never going to cut it to full depth. So the cutting depth here doesn't really matter for these, for the half blinds. You're only cutting, you know, generally halfway through the material. So you're cutting, you know, a 1/4 inch, maybe a little bit more, depending on how thick your material is. But, you know, this distance, you have to know that distance. So if you work through, these are the only two measurements you need. Exactly. It's the width of the bottom and what the angle is. So
it's like you read my mind.
Yeah, I tell you, we're like a well-oiled machine. So what I wanted to do is I got half at the bottom. If I figured out how deep it had to be to cut 3/8 of an inch wide, then I'd have a nice even number, 1/2 inch and 3/8 at the top of the cut. So I just drew a center line, offset it by 3/16 on both sides, and basically made the little stub there. And this is really the part that's cutting. The rest of the bit up here doesn't matter. It's just the business end of it. But this is the part that's cut. It's a 1/2 inch at the bottom. It's 3/8 at the top of the cut. And to get that 3/8 of an inch, it's a little better than a 1/4 inch deep of cut. So, where are we going here? I got to zoom out now.
Man, this is fancy
Isn't it
stuff.
something? Bill. Yeah, I'm using VCarve as PowerPoint.
I see that.
So, if you can imagine all those little pieces, this is the thing we're going to make. This is the thing you just showed in SketchUp. And here's what the bit does. So the bottom of the bit is cutting this whole thing here. I'm looking at the side of the bit, but the top of the part. So it's a little confusing. But here, the top of the bit on the tails, I guess, is leaving the high point.
Right.
And so the bottom is actually cutting. There's an undercut on this part. Let's see if we can show. So it sort of looks like if you offset these things this piece is this one.
Right.
And this piece is this one. So we're looking at it in this orientation. Let me move these around just a little bit. Oh, it's stuck together. Darn it. Oh well, we won't worry about that. But basically, that's what we're looking at. This is going to be a pocket, and this is going to be a raised part. So if you offset, this is a 1/2 inch. The top part of the tail is a 1/2 inch. But the bottom part that the actual bit is going to cut, the bit is going to cut sort of inside here, the bottom of it. And it's going to leave this sort of island. So if you offset this top part by 3/16, you get the actual path of the bit, because it's only going to cut 3/16 wide at the top.
Which is half the width
of the top part of it, the top part of the bit. So I just did an offset of those, and I made these, basically gave this.
And just to clarify, you're saying the top of the cutting portion of the bit.
Right, the top of the cutting part.
Yep.
The top, it's cutting with that part right here, that 3/8 part.
Yep.
Even though the piece is actually sort of the bottom part of this, it has this undercut. But the software just says you couldn't do a 3D model of this and tell it to cut it, because it just couldn't do it. It couldn't get underneath there. It doesn't understand any of this.
The bit would just plow straight down through, and you would not have the back cut from the. angle of the
They
bit.
wouldn't,
Right.
wouldn't know about it. So I'm just telling it, this business right here is really, it thinks it's cutting a smaller piece here. And these are just the center of this arc. The bit has to come in and stop right there as it comes in. So it just makes a little zoop. So I could cut all these things that way, just as little straight cuts. The issue is, and you think that you could just connect all this and join it all together. But the tricky part is, it can't happen. The bad part is, because there's little kind of simultaneous straight sections right here.
Yep.
That are right over top of each other. So if we try to connect those, it still gives me 5 open.
Gotcha. Yep.
So I cheat a little bit. Let's go over here and see. So if I take those and go into the resize and turn off this link X and Y and make that, instead of 875, make it 8, so make it 1/1000th of an inch smaller in width without height. Just, I mean, a tiny amount. It doesn't make any difference to the joint. And if I do that to all of them, then I can take all those endpoints and drag them up to this center line. But with that one, so they coincide there, but they're just a tiny bit apart here, just 1/1000th of an inch apart.
Right. Yep. And so when that bit makes the turn around it, it's actually going in at an angle like that. So from the face that you would see the joint is tight.
Right. It doesn't have any, that 1/1000th of an inch is inconsequential. But it allows
call it a glue pocket.
Yeah, well, I mean, you want to leave a little bit of a glue pocket. Anyway, but yeah, so it gives a nice kind of tapered fit.
Right.
So we do that to all of them, and you end up with something that you can then, let me go back to here.
They look like dead smiley faces.
Yeah, so you can take all these things now, and they're basically just, they're exactly the same here.
Yep.
But I take all them, and I select them all, boom, boom, boom. And I join them, and miraculously they're one thing now, instead of being 5 separate ones. Just because it doesn't have that overlapping line, I've just sort of split that little tiny bit apart. So basically, you could cut this just the way it is, except for your bit would plow down and chew all this stuff up where it comes in and goes out.
Right.
So the last step is to add a couple little extra pieces to it.
Which is
I'll pull this away.
Back the bit.
Yeah, so this does, it starts down here away from the material, and I'll put it all together in a minute, but it's easier to see this way. And then it sort of trims a little bit off the edges to get a good clean. If it just went and plowed in, you would tear up, let's see, you would tear up this edge right here if it just started doing the cutting. So it just makes a real shallow pass along here, just with a little tip of the dovetail bit, goes in a little bit and trims off again, and then it's ready to go to town. So when it's all done, it comes in. This is your start point down here. It comes in, makes that little trim pass, makes one more little trim pass, goes in, trims the edge of this piece, starts cutting, zip, 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 and then has one more piece that exits. So when this is all joined together, let's see if it's joined. It's joined together now. And this is the start point. It comes in, does this across, in, boop, 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 gets to here, comes out here to the end.
So Bill, let me stop you there. Let me ask you a question. Your start point is always determined by where you started the drawing in VCarve, correct?
No, no, sir.
So how did you determine the start point?
So I go into the node part, node editing.
Right.
And if you right click make start point. So I can run it
I've
backwards.
never seen that.
That's a amazing tool, because there's lots of times you need to change the start point.
Gotcha.
It affects on a line that's an open line. It affects whether what's inside and what's outside.
Yep.
It changes a lot of stuff. You can also just hover over it and hit the P button on your keyboard.
Okay.
And that's the shortcut for point. But yeah, being able to change the start point makes a world of difference.
So I have not had a real need to do that yet, but I've wondered about it several times. And what I realized is that when you start drawing, typically from wherever you start your drawing, that just stays as the start point.
Right, and
I just haven't had a real reason yet to correct that. So that's good.
Well, sometimes it starts on a corner, and you may not want it to start on a corner, or it'll start in the middle of a notch or something like that, which is kind of a
yeah. There's been a few times where it's a little funky, but it's good to know.
I tell you what, it really works is in things like all these ear savers I'm cutting. So I'm cutting like 450, 500 of them out of a sheet. And I want the start point to be at a place on it where the piece is connected to the rest of the sheet as long as possible. So I don't want to have it at the bottom of a part, because as it works its way around, all of a sudden it becomes unattached before it's finished cutting. If it's at the top, it stays connected until that last little bit of cut.
Gotcha.
So this is the last piece of this puzzle. Let me see. There we go. Is lying to the, I think we talked about this in an earlier episode, is sort of lying to the software and creating an end mill that's the same as the large diameter of the dovetail bit. And just ignore, I put the angle in the, and misspelled it actually, in the notes part. But you want to make sure that the large diameter is the diameter that you put in the bit.
Right.
And that the depth of cut is greater than you'll ever want to have any of your dovetails cut. It can't cut it in multiple passes without doing something weird in half blinds. Now it can in some situations, but you really kind of want to cut it in one pass if you can. So you just make that number, this pass depth number. So let's go back.
And I'm going to interject there too. I found in cutting 1,000 of these things last week, I found that the spindle speed was really too low, and I ended up bumping it up quite a bit. It made a big difference in the quality of the cut. So I have cut a million of these things with dovetail jigs over the years, and it just occurred to me after I made a series of mistakes. It occurred to me that if I just treated the ShopBot like it was a handheld router, kind of an on-off deal, what would that spindle speed be?
Wide open.
And it's usually, somewhere around 25,000 RPM.
Right.
And so I arbitrarily set the spindle speed at 25,000, and the cuts came out as clean as they could be. I also found that I broke one of the bits early on when I was trying to set up the jig, just because of vibration. So the tool was cutting at a fairly slow rate, a feed rate, but the bit wasn't turning fast enough. It was causing it, and I had it, I think at 10,000 RPMs or something at that point, and it did not occur to me, which is just one of those things to make sure you stop and think through your process before you really get going. The desktop has the variable frequency drive off the side of the machine, and you physically turn it up.
Yeah.
Rather than like on the gantry tool, you set all that in the software. And I just had kind of taken it for granted that, I had gone through all those steps, and I didn't.
It's easy.
And so
it's easy to forget.
It really is. And so it made a big difference when I sped it up. It was just night and day in terms of the quality.
Yeah, if you're doing it with a quarter cable rig and a router, you turn it on fast.
Well, I mean, I have a couple of the old style Porter cables, you know, that only have a toggle switch.
Yeah,
It's only on and off.
I got the same ones.
You know, and I don't really care what anyone says about, you know, what the proper speed is. There have been a million cabinet makers the world over make a million drawers with those routers with great success. So I think the on off, whatever, 26,000 RPMs or whatever it is, I think it's right on.
Well, you also you adjust the speed when you're doing it. You're adjusting the speed based on the sound and how it feels and all that stuff. The tool can't do that. Once it starts out at a speed, that's the speed.
Yeah.
And you know you're doing, you know, you're sort of calculating the chip load in your head, whether it feels right, whether it sounds right, whether it's vibrating. So you're fixing.
Slow down or speed up.
Yeah, you're exactly doing that, and you can't do that with a CNC machine because it's, you know, it is what it is, what it's set for.
Right.
So I don't know if this made any sense at all, but I've been trying to sort out how, you know, I've just sort of been doing this without thinking about it. It's just sort of.
Bill, I think it's great. I think it's very good information.
Well, hopefully it'll, when people think about it a little bit, and this will end up on YouTube somewhere, and feel free to ask questions. And then you can adjust all the stuff. I did it all for this particular bit, but Stuart used a bit that was a little bit smaller, but a little bit shallower angle. So it wasn't very far off this. I just had to modify a little bit so that instead of just going straight in, it sort of came in, made a loop, and came back on the pockets. I just had to figure out what that width was at the right depth. I basically went through the same steps. And we wanted the same, you're using the same 4 3/8 inch wide board. We wanted to have even, we didn't want to be, you know, sort of offset a little bit. So the spacing of 7/8 of an inch worked just right. We just had to change what the arc of the curve on the tail, on the pins, on the tails, and the width of the little tiny arc on the pockets. So that was the, but I mean, you could do this for, you know, just pick the bit, pick the size. If you like big ones or small ones, or you just sort of go through. It's a little tedious, but it's a one-time thing. Once you've done it, you've got this file forever and ever. Right. You know, it's like a lot of this stuff is like having T-shirts made. You know, if you go to T-shirt places, I want one T-shirt, one custom T-shirt made with this artwork. It's a $500 shirt. If you want to grow some of them, it's $600. You know, right. It's the prep work and the labor. It's the trick. You know, that's what eats up the money. That's the
another piece of advice that I would give everybody is to make sure you've got good sharp bits to start with, and get a couple of them. You know, you make one mistake and it breaks like I did, and you're sort of sitting there going, oh, you know, yeah. there goes a day's worth of, you know, troubleshooting or whatever. I make it a habit to have at least 2 or 3 of whatever I've got when it comes to bits. I mean, you know, I've made the mistake. I haven't made it recently. I should probably knock on something to make sure I don't do it today. But, you know, where you finish cutting something and you grab the keypad and you just send the tool over somewhere to get it out of the way, and it drags right across a hold or something. Yeah. You know, just think.
Up there.
I haven't done it in a while, but you know, but it happens. And that kind of, I mean, it's like dead in the water when it happens.
You know, the more you do things, the bigger chance of it messing up. It's sort of like new drivers. You know, new drivers are so cautious; they're aware of everything. You know, once you've been doing it for a long time, you sort of get in your truck, and all of a sudden you're there, and you don't remember stopping at every red light and all that kind of stuff. Right. It just becomes muscle memory, and that's you know, new folks never cut themselves on tools. It's the guy that's pushed 1 million board feet of lumber through a table saw is the guy that cuts his finger off. Because you just become complacent. You know, it becomes ho-hum everyday stuff.
Yeah. Well, Bill, that was good information.
Did that help you at all? Did that make any sense? And
yes, sir.
Next time, maybe we'll look at the jig and how all the millions of different ways you have to get it just right.
I think that's a good practice. I mean, mine, you know, was from the factory had all kinds of alignment issues, and it wasn't, it wasn't really anyone's fault. It's just the nature of machines.
Yeah.
You take them out of the box, and I've always generally made it a practice to assume that you're going to have to tweak things to get it up and running the right way.
Right.
It looked
on another piece of equipment.
when I sighted everything, it looked like everything was, right on. And so I just clamped it up and started going with it. And as soon as I cut a couple of them, I realized that, fences needed to be squared up and things needed to be aligned. So, yeah, it's good information.
Next we'll do this.
I think I know how to cut dovetails.
We'll do the next one will be the Stuart Unconfuses Everybody show.
I don't know about that. Bill, thank you.
Take care, my friend.
You too.
What are you doing today? Anything?
Oh, we're painting door and drawer parts today. We are going to start installing this big project next week. So we're in the final throes. This is kind of that weekend. It's like it always seems to happen on the holiday weekend when I shouldn't be here. It's like this is the big push this weekend to get everything ready so we can get out the door and get this project behind us and start on the next one.
Great fun.
Talk to you
All right,
soon.
take care, bud. Bye.